Nikola Tesla and the rapid progress in the field of electromagnetic radiation, opened up by the findings of Sir William Crookes, Sir Oliver Lodge, and especially Hertz, induced in Tesla a mania to complete as many patents as he could, summoning his prodigious powers of self-denial, depriving himself of sleep, and exerting the full potential of his will. Tesla unfurled his creations as fast as he could. It was at this time that the grand vision arose of wireless transmission of electrical power, and he simply abhorred the thought that someone else should invent it before he could. Thus, he began to build ever more powerful coils while at the same time continuing his numerous experiments in high-intensity lighting, ozone production, converting AC to DC, and wireless communication. In February 1891, Tesla applied for the first of 3 portentous patents for the conversion and distribution of electrical energy. This invention, which was finalized after his return from Europe, was the mechanical oscillator, a completely unique multi-purpose device. Unlike the Hertz spark gap apparatus, which produced slow, rhythmic discharges, the Tesla oscillator supplied a smooth, continuous current which could not only generate hundreds of thousands, or even millions, of volts but could also be tuned to specific frequencies. Over his lifetime, Tesla said, "I developed not less than 50 types of these transformers, each complete in every detail." The device was, in essence, a small engine with almost no moving parts. The work-performing piston was not connected with anything else, but was perfectly free to vibrate at an enormous rate. In this machine, Tesla proclaimed, it succeeded in doing away with all packings, valves and lubrication, although the utilization of oil was intrinsic to its design. By combining this engine with a dynamo, I produced a highly efficient generator which propagated an unvarying rate of oscillation. Since the current was so absolutely steady and uniform, one could keep the time of day with the machine. In fact, the inventor also used the oscillator as a clock. In June 1891, Tesla came upon an article by Prof. J.J. Thomson. This British scientist, whose work would lead him to a Nobel Prize as the discoverer of the electron, was in the process of directing electrical beams from cathode ray tubes so as to study the structure of electromagnetic energy. These investigations prompted a vigorous exchange in the electrical journals between these 2 men and inspired Tesla to return with renewed zeal to my own experiments. Soon my efforts were centered upon producing in a small space the most intense inductive action. Tesla would describe these exciting results to Thomson in person 6 months later, during the lectures he gave in London. That same year, Tesla took out 2 more patents on AC motors which he owed Westinghouse. He also took out a patent on an electrical meter and a condenser, and 2 on incandescent lighting. On January 8, 1892, T.C. Martin, George Wessler, and George Sheep sent Tesla an invitation to dine and spend an evening. Before your journey to Europe, Tesla's glassblower, David Hürgisel, provided all of the tubes necessary for the trip. Sailing on the 16th, Tesla arrived in London on the 26th. Sir William Preece provided a horse and carriage for the young inventor and invited Tesla. Tesla's plan was to speak before the Institution of Electrical Engineers a week later and leave immediately for Paris to lecture before the Société Française des Électriciens. It must have been gratifying that Preece took an interest, as he was part of the old guard. 22 years, Tesla's senior and one of the patriarchs of the British scientific community, Preece was an amiable gentleman, with a full rich beard, high forehead, wire-rimmed glasses, and an air of self-assurance. As head of the government's Postal Telegraph Office, Preece had worked with telegraphy as far back as 1860 and had brought Bell's telephone, along with Bell himself, to the British Isles in the mid-1870s. He had also been associated with Edison since 1877, having coined the term Edison effect after visiting the wizard in 1884 to study his work with vacuum lamps, and a peculiar effect whereby electronic particles flowed through space from the negative pole to the positive. Using this device as a voltage regulator, Preece returned to England to show his colleagues, especially Ambrose Fleming. After a few days of enjoyable company and ardor of London, Tesla relaxed, and on Wednesday, February, his discourse, entitled Experiments with Alternate Currents of High Potential and High Frequency, was presented. For a full 2 hours, Mr. Tesla kept his audience spellbound. Before such colleagues as J. Thomson, Oliver Heaviside, Sylvanus B. Thompson, Joseph Swan, Sir John Ambrose Fleming, Sir James Dewar, Sir William Preece, Sir Oliver Lodge, Sir William Crookes, and Lord Kelvin. Tesla proclaimed the driving force of his motivation. Is there, I ask, can there be a more interesting study than that of alternating current? We observe how this energy takes the many forms of heat, light, mechanical energy, and even chemical affinity. All of these observations fascinate us. Each day we go to our work ... in the hope that someone, no matter who, may find a solution to one of the pending problems, and each succeeding day we return to our task with renewed ardor. And even if we are unsuccessful, our work has not been in vain, for in these strivings we have found hours of untold pleasure, and we have directed our energies to the benefit of mankind. Any feature of merit which this work may contain, Tesla humbly stated, was derived from the work of a number of scientists who are present today, not a few who can lay better claim than myself. Looking about the room, and with a gleam in his eye, Tesla continued, one at least I must mention. It is an name associated with the most beautiful invention ever made. It is Crookes. I believe that the origin of my advances was that fascinating little book on radiant energy which I read many years ago. Firing up his great coil, amid erupting thunderbolts, Tesla spoke as if a sorcerer. He announced that with his knowledge, he had the ability to make animate that which was inert. With wonder and delight, we note the effects of strange forces which we bring into play, which allow us to transform, to transmit and direct energy at will. We see the mass of iron and wires behave as though endowed with life. Lamps suddenly burst forth in a variety of magnificent colors of phosphorescent light. Tesla touched a wire, and sparks ejaculated from its end. He created sheets of luminescence, directed electrical streams upon small surfaces, lit wireless tubes simply by picking them up, and erased them by holding a wire from a distant terminal, that is, grounding the effect, or by grasping the tube with both hands, thereby render dark the area in between, and pulling his hands apart in a steady stroke. And just as easily, he would rotate the tube in the direction of axis of the coil and reignite the glow. His theories on the relationship of wavelength to the structure and manufacture of light and his displays of wireless fluorescent tubes prompted one viewer to postulate that the future mode of lighting a dwelling might occur by actually rendering the whole mass of the air in the room softly and beautifully phosphorescent. Tesla unveiled the first true radio tube in this second month of 1892, in the presence of four of the key forefathers of the invention of the wireless. In order to obtain the most perfect vacuum possible, the adept had extracted the air from a bulb that was contained inside another vacuum tube. Within this inner chamber, Tesla generated a beam of light devoid of any inertia. By producing extremely high frequencies, he created an electric brush that was so sensitive that it responded even to the stiffening of the muscles in a person's arm. This brush tended to circle away from an approaching person, but always in a clockwise direction. Noting that the ray was extreme influences, Tesla speculated that its direction of rotation was probably affected by the geomagnetic torque of the Earth. He further expected that this brush would rotate counterclockwise in the southern hemisphere. Only a magnet could get the stream of light to reverse its direction of rotation. I am firmly convinced, Tesla stated, that such a brush, when we learn how to produce it properly, may be the means of transmitting intelligence to a distance without wires. Of all these phenomena, Tesla began, in the next phase, the most fascinating for an audience are certainly those which are noted in an electrostatic field acting through a considerable distance. By properly constructing a coil, he continued, I have found that I could excite vacuum tubes no matter where they were held in the room. Referring to the work of J.J. Thomson and J.S.C. Fleming on the creation of a luminous thread within a vacuum tube, Tesla went on to discuss different methods of exciting vacuum tubes by altering the wavelength or the length of the tube. Setting up a FAN as an analog and discussing the research of Preece, Hertz, and Lodge on the radiation of electromagnetic energy into the Earth and space, Tesla then displayed no-wire motors. It is not necessary to have even a single connection between the motor and generator, he announced, except perhaps through the ground or through the rarefied air. There is no doubt that with enormous potentials, luminous discharges might be passed through many miles of rarefied air, and that, by thus directing the energy of many hundreds of horsepower, motors or lamps might be operated at considerable distances from stationary sources. based on research conducted the year before, which had been prompted by the work of J.J. Thomson in propagating streams of electrical energy. Tesla expanded upon his high-intensity button lamp, a device that could dematerialize or vaporize matter. This arrangement, as we shall see, is precisely the configuration required to create laser beams. Most likely, Tesla displayed actual laser beams at this time. However, neither he nor the other scientists present at the time recognized the unique importance of the directed ray, as it was part of a combination of other lighting effects which resulted in the disintegration of the material that was being bombarded. There are two types of standard lasers which correspond to Tesla's work. One Arab laser, quick reflexestry, which in turn stimulates more atoms into emitting special radiation, and two Argus laser, which consists of a tube filled with helium and neon. High voltage is applied across two electrodes near the ends of the tube, causing a discharge to take place. In both instances, the excited atoms are contained in an enclosure and then reflected into one specific direction. They differ from ordinary flashlights not only because they emit uniform wavelength of light, but also because there is a pausing metastable state before the IGHT is emitted. Tesla worked with lamps constructed in exactly these ways. The first he called a button lamp, the second an exhausted or phosphorescent tube. Their prime function was as efficient illumination devices. Their secondary functions were as laboratory apparatus for a variety of experiments. In one tube filled with rarefied gas, once the glass fiber is heated, the discharge breaks through its entire length instantaneously. Another bulb was painted on one side with a phosphorescent powder or mixture and threw a dazzling light, far beyond that yielded by any ordinary phosphorescence. A common experiment of mine was to pass through a coil energy at a rate of several thousand horsepower, put a piece of thick tinfoil on a stick, and approach it to that coil. The tinfoil would not only melt, but it would be evaporated, and the whole process took place in so small an interval of time that it was like a cannon shot. That was a striking experiment. Tesla also constructed a type of button lamp which could disintegrate any material, including zirconia and diamonds, the hardest substances known to exist. The lamp was, in essence, a globe coated inside with a reflective material like the Leyden jar and a button of any substance, most often carbon, which was highly polished and attached to a source of power. Once electrified, the button would radiate energy which would bounce off the interior of the globe and back onto itself, thereby intensifying a bombardment effect. In this way the button would be vaporized. Tesla next described precisely the invention of the ruby laser. Over 5 decades before its reappearance in the middle of the 20th century, the description is quite explicit. In an exhausted bulb, we can concentrate any amount of energy upon a minute button of zirconia, which glowed with the most intense light, and the stream of particles projected out was of a vivid white. Magnificent light effects were noted, of which it would be difficult to give an adequate idea. To illustrate the effect observed with Araby drop ... at first one may see a narrow funnel of white light projected against the top of the globe, where it produces an irregularly outlined phosphorescent patch. In this manner, an intensely phosphorescent, sharply defined line emphasis added corresponding to the outline of the drop-fused ruby is produced, which spreads slowly over the globe as the drop gets larger. A more perfect result used in some of these bulbs involves the construction of a zinc sheet, performing the double office of intensifier and reflector. The inventor's talk ended with the speculation that with improvements in the construction of long-distance cables, his suggestions, telephony across the Atlantic would soon be possible. It is significant to note that at this moment, he did not yet envision wireless transmission of voice, but rather wireless transmission of intelligence susceptible to magnetic light and power. His discussions with Prius, however, on the existing of earth currents was beginning to take hold, and shortly afterward, Tesla began to conceptualize the idea of transmitting voice and even pictures by means of wireless. It has been my chief aim in presenting these results to point out phenomena featurefully, Tesla concluded, and to advance ideas which I am hopeful will serve as starting points of new departures. It has been my chief desire this evening to entertain you with some novel experiments. Your applause, so frequently and generously accorded, has told me that I have succeeded. At the end of the lecture, Mr. Tesla tantalizingly informed his listeners that he had shown them but 1/3 of what he was prepared to do, and the whole audience remained in their seats, unwilling to disperse, insisting upon more. and Mr. Tesla had to deliver a supplementary lecture. It may be stated, as Mr. Tesla mentioned, but which hardly seems to be realized, that practically the whole of the experiments shown were new and had never been shown before, and were not merely a repetition of those given in America. Having seen the inventor handle such enormous voltages so unconcernedly, many of the attendees mumbled surprise among themselves and gathered the courage to inquire how Tesla dared to take the current through his body. "It was the result of a long debate in my mind," Tesla replied, "but through calculation and reason, I concluded that such currents ought not to be dangerous to life any more than the vibrations of light are dangerous. Consider a thin diaphragm in a water pipe with to and fro piston strikes of considerable amplitude. The diaphragm will be ruptured at once," the inventor explained by analogy. "With reduced strokes of the same total energy, the diaphragm will be less liable to rupture, until, with a vibratory impulse of many thousands per second, no actual current flows, and the diaphragm is in no danger of rupture." So with the vibratory current. In other words, Tesla had increased the frequency, or alterations per second, but reduced the amplitude or power greatly. The wizard thereupon fired up the coil once again, sending tens of thousands of volts through or around his body and illuminated two fluorescent tubes which he held dramatically in each hand. "As you can see," Tesla added, "I am very much alive." "That we can see," one member responded, "but is there no pain? A spark or course passes through my hands and may puncture the skin, and sometimes I receive an occasional burn, but that is all, and even this can be avoided if I hold a conductor of suitable size in my hand and then take hold of the current." "In spite of your reasons," another concluded with a shake of his head, "your speculation resembles to me the feelings that Armin must have before plunging of the Brooklyn Bridge." In listening to Tesla's statement that he had only shown part of what he had prepared, the perspicacious Professor Dewar, inventor of the Dewar flask, or everyday hot or cold thermos, took the inventor at face value and realized that there was more information to impart. The wizard had simply run out of time. As a member of the board of the Royal Institution, also situated in London, Dewar knew that there were many dignitaries who missed the grand event, especially Lord Rayleigh. So he set himself the task of persuading Tesla to present an encore the following evening. After the talk, Dewar escorted Tesla on a tour of the Royal Institution, where he displayed the work of his predecessors, especially Michael Faraday's apparatus. "Why not stay for one more performance?" Dewar inquired. "I must go to Paris," Tesla insisted, keeping foremost in his mind his desire to limit the time of his visits at each stop so that he could return to the States as quickly as possible. "How often do you think you will have the chance to visit the laboratories of such men as Crookes or Kelvin?" Dewar asked in his Scottish brogue. At the same time, he invited Tesla to visit his own lab, where he was creating extremely low temperatures that approached absolute zero, and conducting pioneer studies of electromagnetic effects in such environments as liquid oxygen. You've already lived in Paris. Now see London. End of Nikola Tesla and the Royal Society Part 1. Thank you for watching.